Okie doke. Hello, everyone. Afternoon, morning, depending on where you are. Thank you very much for joining us for our 194th Reading Online Sports Economics Seminar. It is a great pleasure to have Raphael Flepp presenting his paper, Suspense and Surprise in European Football. Before he does so, I want to flag up three abstract deadlines in the next few days for conferences. First one is very relevant in the sense that it's a conference that Raphael is organising at the University of Zurich. The second workshop on sports, economics and natural experiments, which is going to be on the 27th of June in Zurich. The deadline for submissions is on Monday, March the 31st, which is also the deadline for the 11th Football and Finance Conference for abstracts. And I will put links in for both into the chat. And I'll send, once Raphael starts, I'll send a late reminder to everyone so that you have something in your inbox with these bits of information as well. The final thing, the Duisburg Conference, 11th Football and Finance Conference, is on May the 6th and 7th. And then also on the 1st of April, so Tuesday of next week, is the abstract deadline for the 19th Sports Economics Conference in Gijón in Spain. And that conference is going to be the 9th and 10th of May. So do submit to those conferences if you tend to. Don't miss the deadline. And for now, Raphael, please do take away your talk.
Great. Yeah. Hi, everyone. Thank you so much for having me, James. I'm very excited to present one of my ongoing research projects about suspense and surprise in European football. Although I don't want to claim all the credit, right? So this is joint work with Tim Pawlowski and Travis Richardson. So a little spoiler alert, this paper aims to approach competitive balance and outcome uncertainty from a different angle, right? But let me begin by motivating the paper in the light of what we already know and the complications that also arise with the current state of the literature. So our starting point is basically that competitive balance and the relationship between competitive balance and sports demand have been significant areas of research since the seminal works of Rothenberg and Neal. And the common understanding in this literature is that a certain level of competitive balance between teams and athletes translates into a certain degree of uncertainty at different levels. And this basically goes back to Stefan Szymanski's paper in 2003. So there is uncertainty over the outcome of a single game. So that's the short-term perspective. Then there is uncertainty over the outcome of a sub-competition, such as the championship, for instance, championship race in one season. So that's the mid-term perspective. Or there is even uncertainty over several years in terms of dominance of a few teams. So that's the long-term perspective. And similarly, there are different conceptualizations of competitive balance at different levels as well. And in this paper, we use the term short-term competitive balance as it is used in Pawlowski and Nalbantis 2019, which refers to match level. Okay, so our focus is going to be on match level. And here the argument is as follows. A certain level of balance in playing strength between two teams in a match translates into a certain degree of match uncertainty. And then match uncertainty itself should be positively associated with sporting demand. So that's the famous uncertainty of outcome hypothesis. But there is this really intuitive relation between competitive balance, match uncertainty, and sporting demand. And league organizers and also policymakers, they rely on exactly this argument, right, when they regulate sports to increase competitive balance. Why? Well, the regulation is justified because it's in the fans' interest, basically. Now, what is the complication in this literature? Well, as it turns out, the empirical research has actually struggled to find consistent support for the relevance of match uncertainty as a key factor influencing sporting demand. So, for instance, a recent meta-analysis by Collins and Brett Humphreys shows that only about 30% of all the models they include in their study actually support the standard uncertainty of outcome hypothesis. And then Johnson and Ford, they relaxed this a bit and say, well, if we do not find the opposite effect, so evidence for the opposite being true, we cannot actually reject the uncertainty of outcome hypothesis. But even then, only approximately 47% of all the regression models they include fail to reject the uncertainty of outcome hypothesis. It also turns out that there are some differences across sports, but most importantly for our paper, there seems to be a lack of consistent evidence for the relevance of the uncertainty of outcome hypothesis, especially in European football. Okay, so that's basically the area or the sport where we lack consistent evidence. So this actually means that measures of short-term competitive balance and match uncertainty as well that are consistently associated with fan welfare are currently lacking. And now the question is, okay, so what should we do? We have this intuitive uncertainty of outcome hypothesis, but we are lacking empirical evidence or consistent empirical evidence. Well, first, we could try to explain why we don't find consistent evidence for it, or we can approach the problem from a different angle. And that's the second one. The latter is actually what we aim to do. So instead of starting from short-term competitive balance, which translates into match uncertainty, and subsequently into sporting demand, we reverse the chain. So we start with something that fans care about, and that is related to match uncertainty, so that we can use it as a measure that actually reflects short-term competitive balance that matters for sports demand. Okay, and this is essentially the main pitch of the paper. So if you leave the seminar remembering this logic, and it makes sense to you, that's perfect. Okay, so what do fans care about? Well, we already know from the previous research that fans care about suspense and surprise. And suspense is a forward-looking measure that generally refers to the excitement or also the anxiety about what will happen in the future. Yeah? And surprise is a backward-looking measure that generally refers to the emotion triggered by an unexpected event. And we propose that suspense and surprise as promising measures for short-term competitive balance in the context of European football for mainly three reasons. So first, several empirical studies have already demonstrated that the demand for sports is driven by both suspense and surprise. For instance, Pizzotto et al. 2016, in which I was also involved, we examined minute-by-minute suspense and surprise in tennis and related these measures to TV ratings. Similarly, in Buraimo et al. 2020 and also Richardson et al. 2023, they conducted a similar analysis in the context of European football. And Simonov et al. Investigated suspense and surprise in the context of esports and streaming demand. And based on this empirical evidence, it's pretty clear and pretty consistent empirical evidence that both suspense and surprise are important drivers of sports demand. Second reason is if you think about it, those are actually suspense and surprise are actually closely linked to outcome uncertainty. However, in opposing ways, in opposite ways. So suspense is expected to increase with increasing levels of uncertainty. However, the potential for surprise increases with decreasing levels of uncertainty. So in order to have a really big surprise to happen, less uncertainty is needed. Okay, and this surprise element has been mostly ignored in the competitive balance literature. And finally, final reason why we propose those two measures is that suspense and surprise are derived from information revealed in each period within a game or within a football game. And so to calculate match level, suspense and surprise, we will first estimate both measures at the very granular level. So in our case, it will minute by minute, before we then actually aggregate them over the entire match. And this bottom-up approach is very well suited for analyzing competitive balance, as it allows an aggregation at virtually any level we desire. So we can aggregate it at club level, at the league levels, or even at the European level, okay, because we have this bottom-up approach. And this method enables a more detailed examination of the patterns and the trends. Now, taking all these considerations into account, we derived the following 3 research questions that we want to tackle in our paper. First one is, okay, how do match level, suspense, and surprise depend on the relative strengths of the teams in a match? How do suspense and surprise in European football matches compare to those in a perfectly competitively balanced match? So what is the current level that we are right now? And how have those 2 metrics evolved over time? And we believe that these are really important questions if you want to understand the current state and also the recent developments of European football in terms of this short-term competitive balance, using measures that have been shown to significantly impact sporting demand. Okay? Does that sound interesting? I hope. Great. All right. Now, how can we conceptualize and measure suspense and surprise? Well, we could ask people, right, to watch the entire match and then report their perceived levels of suspense and surprise, ranging from low to high. Would be tricky to get a reasonable sample size because people would have to watch thousands of matches, right? So what we do is basically we closely follow the conceptualization proposed by Eli et al. In their 2015 JPE paper. And now the neat thing in sports is that on match level, the beliefs are formed about the probabilities of the final match outcomes. So basically, what is the probability that the home team wins in any given minute during the game, given the teams playing, given the current score, and the time remaining? And what are the probabilities of a draw and an away team? So the beliefs are about the final match outcomes. So let's start with looking at how we calculate or derive surprise. So surprise is a backward-looking emotion or measure that arises when an unexpected event occurs. So it's all about what just happened. So it's going to be the difference between the outcome probabilities in minute t and minute t minus 1. And the period generates more surprise if the current belief about the outcome is farther away from the last period's belief. So for instance, surprise in football is high when a team scores against all odds. Okay, so then we're going to have a big surprise. So we start by calculating surprise at the minute-by-minute level before then aggregating it over the entire match. So over the 90 minutes with all extra time condensed into minute 45 and minute 90. Now, in contrast, suspense is forward-looking. So at time t, the viewer wonders, okay, what could happen next? And now the question is, how would the outcome probabilities change if a team were to score a goal in the next minute? Okay, so forward-looking. So we need these additional what-if beliefs. So those are the hypothetical changes in outcome probabilities from minute t to t plus 1. If either team scores in the next minute, and we weight it by the probabilities that either the home team or the away team is actually scoring. So basically, what would be the new outcome probabilities if a team would score, and how far away are these new outcome probabilities from the current one? And in the end, suspense in a particular minute will be higher if the variance of the next minute's outcome probabilities is greater. That's how you could think about it. And again, we sum suspense generated in each minute up to get the match level values of suspense. So basically, in the end, we obtain one suspense measure and one surprise measure per match. And now, obviously, we need to estimate the outcome probabilities. So we need to estimate the outcome probabilities on minute level, given the current state of the game, time remaining. We need to estimate the probabilities of either team scoring in the next minute. And we also need the hypothetical outcome probabilities in the next minute if a team were to score. And to do that, we employ the in-play model proposed by Buraimo et al. 2020. And the core assumption here is that European football matches resemble a Poisson match, where goals are scored follow univariate Poisson distribution. So that's the main assumption behind this in-play model. And in short, we first need the scoring rates of the home and the away team per match. As you're going to see in our simulation approach, we set those exogenously. In our analysis of the real matches, we will estimate the scoring rates based on betting odds. And once we have those scoring rates, we can derive the scoring rates per minute. And based on the scoring rates per minute, we can estimate the needed outcome probabilities given the current state of the match. However, this approach is not new, so it basically mirrors the method proposed by Buraimo et al. Okay, now, to understand how match level suspense and surprise depend on the team's playing strength, reflected by the scoring rates, we start with simulating football matches. Okay? And in particular, we simulated 10,000 matches for each scoring rate match up between 0 and 5, using increments of 0.1. Okay, so remember, European football is a low-scoring sport, so a scoring rate of 5, meaning that a team is expected to score 5 goals in a match, is already quite high. Okay, so 5 goals per match, I would say, pretty high. So we simulate all those matches between scoring rates of 0 and 5. And what do we observe from this simulation exercise? Let's start with suspense on the left. So suspense tends to be higher, so more of the red color, for lower and more equal scoring rates. So the maximum suspense is achieved or generated if a match has 2 teams with equal scoring rates of 0.5. So really low scoring rates. Note that in the left bottom corner, when both scoring rates are equal to 0, the match is perfectly balanced, right? But suspense is 0 because the outcome of a draw is certain. So this is also an important difference between competitive balance and suspense or match uncertainty. Okay, so in this case, perfectly balanced but 0 uncertainty. Now, most importantly, when we look at the graph, you see that even if the match is perfectly balanced in terms of the scoring rate, so you can basically draw this 45-degree line, and on this line, the teams are perfectly equal in team strength, right? But even if we are on the line, suspense values change. Okay, so suspense also depends on the absolute level of the scoring rates. Okay, so if the scoring rates are balanced but pretty high, 5, suspense is going to be lower than when the scoring rates are balanced but lower in absolute terms. Okay. Now, when we look at surprise on the right, we see that surprise strictly increases with higher and more balanced scoring rates. And the maximum surprise can be observed at lambdas of 5 for both teams. Okay, so that's basically the upper boundary of our scoring rate. So in this example, or in this case, surprise is maximized at scoring rates of 5 for both teams. Now, overall, these results quite nicely highlight the trade-off between suspense and surprise, even if the matches are perfectly balanced. Okay, so lower scoring rates tend to increase suspense, but lower surprise, whereas higher scoring rates tend to decrease suspense and increase surprise. And now we can use these simulation results to derive a benchmark or a benchmark range of both suspense and surprise in perfectly competitively balanced matches, characterized by equal team strengths, but varying scoring rates. Okay. Now the question is, okay, what values of suspense and surprise could we expect given a perfectly balanced match? Well, we don't really know because it clearly depends on the level of the scoring rates that we would have, right? So we will end up with a range of values that all stem from a perfectly balanced match, but different scoring rates. Which scoring rates would be realistic? Now, if we look at the empirical goal distribution in European football, most of the average scoring rates per team in a match turn out to be between 0.5 and 2.5. Okay, so the scoring rate of 0.5 corresponds to the 10th percentile of the distribution of the average number of goals scored by a team per match. And the scoring rate of 2.5 corresponds to the 90% percentile of this distribution. So basically, 80% of all the matches we observe, average scoring rate is between 0.5 and 2.5. And now, within this benchmark range, Suspense has a lower bound of 6.03 and an upper bound of 6.89. Okay, and we can do the same for Surprise, so using the same boundaries of the scoring rates. And here, the lower value of Surprise will be 1.17, and the upper bound will be 1.74. Okay, and these values basically establish the boundaries of our benchmark range, derived from perfectly balanced matches against which we will compare the empirical values of Suspense and Surprise from real matches. Okay, enough with the simulations. Let's calculate Suspense and Surprise for real matches. And let's start with men's matches. Okay, and our data set comprises over 25,000 matches played in the top 5 European leagues. So we're going to have the Premier League, German Bundesliga, La Liga in Spain, Serie A, and Ligue 1. And our data set covers a period of 14 seasons from 2010 to 2023. And for each match, we collect the timing of the goal scored and the red cards received from fbref.com. And we added the pre-match closing odds as well as the over-under odds from oddsportal.com. Okay? And these odds are then used to backwards engineer the scoring rates. Okay? But again, we are following the methods of Buraimo et al. Here. Okay? So we need the betting odds to come up with the scoring rate. Now, the descriptive statistics of match level, Suspense, and Surprise are displayed in the table. And I think they are already very insightful. So the first thing we see is when comparing the average values per match across the league, we see some variation between the leagues, right? So the Premier League, for instance, exhibits the lowest values of Suspense and Surprise. So it's 4.74 and 1.38, so the lowest values across the leagues. Average Suspense value per match is highest for the French Ligue 1, while the average Surprise value per match is the highest for the Bundesliga. Now, the second and more important observation is that the average Suspense from a perfectly balanced match is higher than the average Suspense from real matches. Okay, so for instance, if we look at the Premier League, average Suspense is 4.74, which is obviously lower than the lower bound of our benchmark range, which was 6.03. And we can also test this more formally using a t-test and find, well, indeed, these values are statistically different from each other, indicated by the stars here. And the same is basically true for all other leagues, okay? Suspense values, the real ones, are significantly below the lower bound from our benchmark range. Now, this is not totally unexpected, right? Because there is clearly some imbalance in terms of team strengths in European football. Now, by contrast, in terms of Surprise, the average level from the Premier League, for instance, is higher than the Surprise generated from a perfectly balanced match with a low scoring rate. Okay? Lower boundary equals 1.17, surprise values in the Premier League are actually a bit higher. And this is also true for all other leagues, right? So in terms of surprise, European football seems to be doing quite well, lies well within the benchmark that we derived. And now the cool thing is that we can go even further and analyze the trends in suspense and surprise over time for certain leagues and certain teams separately. Okay, so let's zoom in some individual leagues to see what the pattern look like in more detail. Let's look at suspense in the Premier League first, and let me build up this graph step by step. So right now it looks quite innocent at the beginning, but not so much at the end. Okay, so the graph just displays the average suspense from all matches per season individually for matches involving each of the top 3 teams and all other teams. Now, what are the top 3 teams? We defined them as those with the most points won during our time frame. Okay? And in the case of the Premier League, these teams are Manchester City, Liverpool, and Arsenal. Okay? So those won the most points during our 14 seasons. And we basically track the development over 14 years or 14 seasons. Now let's add the benchmark range from our simulation analysis. So the range of average suspense arising from this perfectly competitively balanced match. And you see, well, top teams, they are often below the band, quite often. But for matches involving any other teams, not that much, right? And we can also test whether the seasonal averages are significantly below the lower band of the benchmark range using a simple t-test. So if the difference is significant at the 5% level, we indicate this by a little star at the top. Okay, so notice the star at the top. Whenever you see the star, it indicates that the average is significantly below the lower band. So what are the main takeaways so far? Matches involving Man City, almost always significantly below the lower band. For Liverpool and Arsenal, pattern is similar, but somewhat less pronounced. For all other teams, they are only sporadically below. And mostly not significantly below. Now, these are only average suspense values, right? So what about the variation of suspense? Is every match of Man City boring, for instance? Well, I would say quite the opposite. So we can clearly see this when we add box plots. Okay, so bear with me. When we add the box plots, you see half of the observations are within the box plots. And we observe a large variation in match suspense for every single match. So even for Man City, there is a huge variation, and it could be like a really high suspense for any single match. Now, to formally investigate the magnitude of the time trend, so those was about the level, right? Now, to investigate the time trends in suspense and surprise in the Premier League, we estimate linear regressions, and we use the natural log of suspense as the dependent variable, and just the season year as a continuous independent variable. So very easy regression, linear regression. And the key insights from this is basically displayed in the box in the upper right. Only matches involving Man City have significantly decreased in suspense over time. So effect size is quite substantial, 4% per season. And whenever a team is displayed in bold, that indicates a statistical significance at least the 5% level. Other than that, there's not so much going on, and the estimates are not statistically significant. So there tends to be somewhat decrease in the Premier League and also for Arsenal, but those are not statistically significant. So here it's basically Man City that Man City matches that decrease in suspense. Okay, let's focus on surprise. Now that you are familiar with the graph structure, right? I show you the whole graph at once. So let's again compare the empirical surprise values per league and season to the surprise values from our hypothetical perfectly balanced matches. And interestingly, here most empirical average surprise values lie within the benchmark band. Okay, so there is one exception, Man City in the 2018-19 season. This is the only season where Suspense is significantly below the lower benchmark range, as indicated by the little star at the top. So the implication is basically in terms of surprise, the Premier League is also doing quite well, and this is also true for the top teams. Okay. Now again, how has surprise developed over the last 14 years? If you look at the results at the top, surprise has significantly decreased for matches involving Man City again, so approximately 2.5% per season. But for all the other teams, it did not really change. Okay, so the point estimates are close to zero and statistically insignificant. Okay, now we can construct the same graph for the Bundesliga, and we observe very different patterns. Okay, so let's start again with Suspense. Graph structure is basically the same as for the Premier League. Now the top three teams are Bayern Munich, Dortmund, and Leverkusen in this case. Again, defined as the teams that won the most points within the 14 season, along with the averages of all the other teams. And we can clearly see that the average Suspense values for Bayern Munich matches are consistently the lowest in the Bundesliga and significantly below the lower bound of the Suspense benchmark band. Now, matches involving Dortmund have the second lowest Suspense values, with many seasons also significantly below the lower band of our benchmark band, right? So basically, the Bundesliga can be characterized by Bayern and Dortmund matches generating low Suspense, while matches involving other teams remain closer to the lower benchmark band. Now, again, the linear regression results reveal a significant negative trend for the non-top teams, in this case, in Suspense in the Bundesliga. However, the magnitude of the effects appears somewhat modest, right, with Suspense decreasing with approximately 0.7% per season. A bit stronger for Leverkusen, but most importantly, this negative trend is not observed for either Bayern or Dortmund. So we have the two most dominant teams, but we do not see any decline in Suspense in the Bundesliga. In terms of surprise, the values in the Bundesliga fall again pretty well within the benchmark band, with some notable exceptions of matches involving Bayern Munich. And over time, the development of surprise has a slightly negative trend for matches involving non-top teams again. So the pattern is similar to the Suspense development in the Bundesliga. And again, this trend does not hold for either Bayern or Dortmund. So if anything, it even appears that the matches involving Dortmund have become somewhat more surprising over the 14-year observation period, although this is not significant at the 5% level. And this pattern stands in quite a stark contrast to the Premier League, where it was predominantly matches involving one top team, Man City, that showed a significant decrease in both Suspense and surprise. Okay. And now, if we compare these results to those from the Spanish La Liga, we observe yet another distinct pattern. Okay. Here, let's start with Suspense again. In the Spanish La Liga, top three teams, you might have guessed it, Real Madrid, Barcelona, and Atletico Madrid. What can we observe here for the Spanish La Liga? Well, first, in terms of the level of Suspense, matches of both Barcelona and also Real, they used to be very low at the beginning of our sample period. So, and usually also significantly below the benchmark band, as indicated by the stars at the top. For Atletico, we see a similar but somehow less pronounced pattern. Okay. However, the values of all other teams, they usually lie within the benchmark range. And second, in terms of the development of suspense over time, we see that the values of all teams significantly increased over time. Okay? So for all other teams, although quite a small increase with 0.6% per year, as suggested by our linear time trend coefficient. However, matches involving Real and Barca, they have increased much more with 4.5% per year and 5.6% per season, respectively. Okay, so overall, in La Liga, we clearly see an increasing trend in suspense values during our sample period. And finally, surprise values for La Liga also mostly lie within the benchmark range. Most importantly, I would like to mention the time trends again. So surprise has increased for all teams with relatively large effects or larger effects for Real Madrid and Barcelona. Now, I'm not going into the details for the Italian Serie A and French Ligue 1. The French Ligue 1 basically resembles the Premier League in that it's dominated by just one team, PSG. So we observe a significant decline in both suspense and surprise in PSG matches, but not for any other team. And meanwhile, in the Italian Serie A, there is essentially not that much going on. Okay. What I would like to highlight now is because the paper is about suspense and surprise in European football. So we also include women's matches for the top divisions in the same 5 countries as for men. Okay. Now here we have some data availability limitations, so we restrict our analysis to the 2023-24 season. And overall, we end up with 725 women's matches, but we only have one season, so we cannot do the time trend analysis. But still, I think it's very insightful just from this one season of observations. Now, the main takeaway regarding the average level of suspense and surprise in women's league is very similar to the men's. So the comparison with the lower bound of the benchmark reveals that while average suspense is significantly lower, average surprise also lies within or just below the calculated benchmark bound. And we can do the same exercise here. We can distinguish between top teams and all other teams. And when we do that, I would like to highlight one of the most pronounced difference, which are observed for Barcelona in Spain's Liga F. Okay, so just as an example. So you see, if you look at the suspense graph on the left, that there is only one observation that is close to the benchmark band, and all observations are far below for Barcelona. So Barcelona is the blue team. Okay? The really low suspense values. So this suggests an extreme dominance by Barcelona, making their matches among the least suspenseful and also surprising across all leagues covered. So you see basically the same pattern on the right for surprise. So they really have predictably low surprise value with not that much of a variation going on. And to make a kind of a relation, so Barcelona's women's team generated by far the lowest suspense and surprise values. So their surprise values are at 1.57 and suspense values are at 1.57 and surprise are on average are at 0.37. Okay, so if you compare that to Bayern Munich, so that's the team from the men's competition with the lowest average values. They have suspense values of 4.24 and surprise values of 1.11. Okay, so Barcelona's values are several times lower than those of Bayern Munich, which has the lowest values for the men's competition. And the reason. Well, if you look at the season that Barcelona played, they basically won all but one matches. Okay, they won everything. One match ended in a draw. Okay? During the 23-24 season, and this is kind of reassuring for us that our suspense and surprise measures actually or accurately capture this dominance, right? And I mean, if you look at the results, they turn out to be really dominant, right? So usually they do not win with 1 or 2 goals. They usually win with 5-0, 6-0, or 8-0. So really, large and clear wins. Okay, so yeah, I would like to turn now to the discussion and also the conclusion by first highlighting our key results. So first, our simulation analysis shows that suspense and surprise are influenced by both scoring rate levels and their differences. Okay? And we further identify a trade-off between suspense and surprise, even in perfectly balanced matches. So suspense is higher at lower scoring rates, while surprise is higher at higher scoring rates. Okay? And then next, we compared the actual match data from men and women's leagues to benchmark values derived from perfectly balanced matches. And here the key insights are that suspense levels tend to be lower, the actual ones, particularly in matches involving top teams. However, surprise values mostly fall within the benchmark range. Okay? Now looking at the time trends for men's matches, we find that there is no overall decline in suspense and surprise across European football. However, there are clear league and team-specific shifts. So the Spanish La Liga has seen increasing levels of suspense and surprise, which are accentuated by Real Madrid and Barcelona. So basically, this suggests a shift toward greater short-term competitive balance in La Liga over time. Meanwhile, teams like Manchester City and also PSG, they exhibit declining suspense and surprise, while the values of the remaining teams in these leagues remain pretty stable. Now, what are the main contributions of our paper? Well, first, we contribute to the competitive balance and the uncertainty of outcome literature by proposing those 2 measures and aiming that they represent a novel way to analyze short-term competitive balance. So both suspense and surprise have been shown to be relevant for fan welfare, whereas the empirical evidence on the relationship between traditional outcome uncertainty measures and fan welfare remains pretty mixed at best. Okay? Then second contribution, as suspense and surprise vary even for competing teams of equal strength, we end up with a benchmark range of suspense and surprise in perfectly balanced matches. And this also differs from the traditional methods in the competitive balance literature, which typically defines one unique level of competitive balance based on the theoretically most equal distribution of wins or points or whatever. And finally, our study provides important insights into the current state of both men and women's European football. So while we do not find decreasing trends, while we do find some decreasing trends in the top teams such as Manchester City or also PSG, overall there is no evidence for a really strong decline in short-term competitive balance. And we even see some increasing trends in La Liga, right? So our study basically offers a reassessment of the previous research that suggested a broad decline in competitive balance in European football. What does our paper contribute regarding practical implications? So first, since our paper highlights that there is a trade-off between suspense and surprise, policymakers should consider these trade-offs when they are thinking about designing interventions. Okay, so even perfectly balanced matches face this trade-off between suspense and surprise. So while equalizing team strength may increase suspense, it could also reduce surprise depending on what happens to the scoring rates. Okay? Second, it's also crucial to recognize that short-term competitive balance should not be assessed solely at the aggregated level. Okay? We have seen that the average trends across all leagues might be different than the trends within the individual leagues. And we have also seen that the trends across all the teams within a league, they might obscure trends within individual teams. Okay, so we would say, well, any assessment should be based on kind of a more nuanced approach. And third, looking at the current state in men's football, suspense and surprise levels do not indicate an urgent need for intervention. In contrast, in women's football, there is this one case of Barcelona in Liga F that really stands out. Okay, so the team's extreme dominance results in exceptionally low suspense and surprise, which may warrant further attention. But here we have to be very careful because we only have one season of data. Okay, but given this data, the dominance seems really extreme, and we have not seen such low suspense and surprise level in men's leagues, for instance. But we have to be careful, right? So there's limited data. And now let me highlight acknowledging several limitations of our paper, and also highlighting promising directions for future research. So our current approach focuses on match level suspense and surprise. Okay, so which means we capture only the short-term dynamics within a single game. However, football fans, they also experience uncertainty at the season levels, for instance, such as the evolving title race or any relegation battle and so on. And future research could expand our approach by calculating suspense and surprise week by week based on the league standings and the title probability. So basically, we could change the relevant beliefs to be not about the game outcome, but to be about the league title winner, for instance. Additionally, our model currently relies on major in-play events such as goals and red cards. Okay, so that's basically the only two events we rely on. However, football matches consist of many other moments that could be significant. So think about missed goal chances, some pressure phases, or instances where there's a goal in the air. Basically, we are not capturing those elements so far. And integrating these into our framework could obviously lead to more nuanced measures of suspense and surprise. Another limitation is obviously we are assuming a neutral spectator, and when we assess suspense and surprise. However, fans of a team, they may experience suspense differently than neutral viewers, and rival fans or haters might find even an enjoyment in unexpected negative outcomes for certain teams, right? So capturing how fan loyalty shapes the perceived impact of these elements seems promising and highly relevant also from a league policy perspective. Okay, but so far we just model it for a neutral spectator. Okay, so surprise is going to be high independently of whether it was a good or positive or a negative surprise. And finally, while this study focuses on European football, you could also think about how to apply this framework to other sports. So we believe that it would be very interesting to compare suspense and surprise across different sports, which would also increase our understanding of how the different sports actually create entertainment value in terms of suspense and surprise. Okay. And with that, I would wrap up my presentation, and thank you very much for your attention.
Thank you very much, Raphael. I'm giving you a Teams round of applause. That was really, really interesting talk, very well delivered, really interesting set of graphics as well, very well explained. Thank you very much for that. We have lots of time for questions and comments, so if anyone wants to raise their hand. Please do. Alex.
So thank you very much. Very interesting. Just a technical question. You sum up the minutes for suspense and surprise from 1 to 90. I'm wondering what's happening is it from 1 to 90 or from 1 to the end of the game, which can be 95 minutes, 99 minutes, and maybe there are teams that play significantly more time than the others. Could that affect the result?
So the way we do it right now is we assume that we want to have 90 minutes for all the games so that we can compare the values. So what we do is we add the additional time, which could be from 0 to whatever, to the 90 minutes or to the 45 minutes. Okay, so this is not entirely accurate, I agree. But that's our approach of what we do right now. And obviously, we need to do some robustness checks on that. So one would be take the actual time the game was and calculate over different amounts of minutes. Okay, so if a game takes a little bit longer, we sum it over more minutes. So that could be a reasonable approach. So right now, I don't know how this would affect the results because we haven't done it yet. So, but for us, it was important to start with games that are all of equal length.
Thanks, Alex. Any more questions and comments? Daniele.
Yeah, hi, very interesting. My question, the way that you're calculating the probabilities, so if I understood correctly, you're taking the team odds from, pre-game, and then you're assuming a constant goal scoring probability, or does that depend on game state?
It does not depend on the game state, but to derive the minute-by-minute scoring rate, basically, we draw on the empirical distribution of the goals. Okay? So we are not assuming essentially that so we have an overall match scoring rate, and then we derive the minute-by-minute scoring rate. So the simplest way to do it would just be to say, well, we divide the match scoring rate divided by 90 to get the minute-by-minute scoring rate. So basically assuming an equal distribution of the minute-by-minute scoring rates across time. But what we do is we look at the empirical distribution of the goals for any single league. So for the Premier League, we take the Premier League distribution. For the Bundesliga, we'll take the Bundesliga distribution. And then we basically adjust the minute-by-minute scoring rate by this empirical distribution of the goals. But we do not say that the scoring rate changes based on the current score. Okay, we do not assume implement that. Yeah.
Would that be feasible to do? Because you have the minute-by-minute events, so you could estimate, what is the probability of scoring, of team A scoring in minute 75 conditional on the current game state. And I think that does matter. A team that is 1-0 down or 1-0 up has different probabilities of scoring, even given the actual strength.
Yeah, definitely. I think it would be feasible. Yeah, definitely. Thanks.
Thanks, Daniele. More questions and comments? Yeah, I'll ask a few questions, I guess. Perhaps revealing my lack of understanding, but I guess you're not taking a stance on whether more suspense or more surprise is a good thing or not.
You mean relatively? Which one is more important, or?
I'm just wondering whether because yeah, I guess I think about it, it goes back to that couch potatoes versus fans thing, right? If I'm watching a football match, it doesn't involve my team. I'd like it to be suspenseful. It makes it more interesting. But if it's my team, I don't want it to be suspenseful. I want it to be really easy. I want to be a fan of Barcelona's women's team, to be honest.
Yeah, that would be like the fans' perspective, right? And right now we are just taking this neutral spectator perspective, where any suspense is good and every surprise is good. So the more, the better, basically. But I agree. We need to implement these fans' perspectives as well. So yeah.
I wondered whether, obviously, you mentioned kind of potential policy responses. That given you didn't think that necessarily there's too much to be concerned about in the major leagues. And I wonder if you've traced out the impact of VAR perhaps, or some of the other smaller changes that have taken place over the 14 years or so that you've been looking at.
Yeah, that would be a possibility. Yeah, we could look at how. I mean, basically, any rule change could be investigated, right? So VAR could be one, or when they change the number of substitutions, basically anything, right? Because we have such a fine-grained measure on the match by match level, basically.
Yeah, and I guess so far you haven't necessarily matched this with any kind of measure of fan interest, like stadium attendance or TV viewership. And I guess obviously papers have looked at minute by minute TV viewership. They've used that. I don't know whether that's part of your thinking, part of your planning, because I guess also all these leagues have got quite full stadiums, haven't they? So you couldn't really use stadium attendance to measure whether fans like suspense and surprise or not.
Yeah, I mean, we have it. I can show it, but we didn't want to make the paper about that. So
Right.
so what we because then the discussion is all about that, right?
Yeah.
So here we just to explain it shortly. So so it's basically a validation, right? Are suspense and surprise values relevant, and in this case for TV demand? Okay, so we have the logarithm of the audience per match, so it's on match level, and it's a subsample of 790 Premier League matches played between 2013 and 2018, and it's basically this. It's the sample that they used in Buraimo et al. in the Coach Potatoes paper, right? So it's basically the first regression is replicating their study, and they found outcome uncertainty measured by the absolute difference based on the pre-match betting odds does not matter for TV audience. Okay, and what we do is basically we take the exact same regression that they have, exact same model, so including team fixed effects, controls for derby, controlling for average player rating, for match significance measure, and all that stuff. And we just add our measures of suspense and surprise. We take the logarithm that we can interpret the effect size a little bit better, but basically we see that suspense and surprise, they are positively associated with attendance. Okay, so that's what we see. And outcome uncertainty stays basically zero. But since we only have like a subsample, we decided to put it in the appendix of the paper. We had it in the front at one time, but then the whole discussion was about that. And this is nice to have, but what we actually aim is basically we want to build up on the previous literature that has already shown that they matter, right? But I agree they have not shown it at this level, but on minute by minute level. That's true.
I mean, in principle, you can apply this method to literally any football match that the goal timings and red cards in, right?
Yes, if you have the betting odds. You
But
need the betting odds as well, but yeah.
You could estimate that, right? You use
Yeah,
a
yeah,
different
yeah,
measure, estimate
yeah,
betting
that's
odds
true.
or something.
You could also use ELO ratings to come up with scoring rates, if that would be an option. But basically, so far, you only need the major in-play events. Yes, the goal scoring times and the red card times, if there is any. Yeah.
That seems quite exciting to me. You could apply it to all sorts of different competitions. You could go back decades and decades potentially.
I agree. Yeah, if it's possible, if you don't need the betting odds. So far, our sample was restricted by the use of the betting odds, right? But if you think about it like in a different way and say, okay, let's use the ELO ratings. Yeah, I agree.
Yeah. Well, I'll stop hogging things. Does anyone else got any questions that they want to ask Raphael?
I have another suggestion. I can't put my hand down. Can you hear me?
Yeah, we hear you.
Okay. So, you showed the evolution of the, I mean, obviously sort of, I think, the suspense rating tends to be correlated with, disparity in team strength. It's not perfectly associated with that. And, you showed sort of, Barcelona woman that wins, all its matches 7-0. And the suspense rating is very low for them. But I think it would be interesting if you could compare. So, people have done, I don't know if people, but they've sort of measured sort of the, say, a Gini coefficient in points accumulated during a league season as a measure of how uncertain or how suspenseful a league is, right? And leagues with sort of smaller Gini coefficients seem to be more balanced. But a league could have two leagues could have similar Gini coefficients, but be very different in terms of suspense. And I think it would be interesting to show how those two things line up or deviate. So maybe a team wins all its matches 1-0, so the Gini coefficient in that league will be very high because you have a team that dominates, but the matches are actually all very suspenseful, relative to one in which the same team wins all its matches, but they win all their matches 5-0. So I thought that would be another sort of angle that you could look at.
Yeah, definitely. Yeah, thanks for the suggestion. So you're right. So this one is focusing on the short-term view, right? So it's basically the matches, and then we take the average over different time frames. But it would be very important to basically also include this midterm perspective, right? So that and comparison with the Gini coefficients. Yeah, I like the idea. Yeah, thanks.
Or other measures of inequality.
Yeah, it's true.
There's something related there that kind of interests me at the moment about all these kinds of measures of competitive balance and interest in leagues is the Premier League over the previous 4+ seasons. Is that maybe this, I don't know, this might go back to the fan perception thing that you alluded to at the end, Raphael, but in the last 4 seasons, basically Man City won every season and you knew they were going to win. They had a little shaky spell, kind of November time, and everyone thought, oh, maybe it'll be interesting. But then after Christmas, they won every single match, and you just knew this was going to happen. But despite the fact they won every single match after Christmas, and it was kind of, you should expected it, they never won the league by more than 5 or 6 points or something. So it kind of looked on balance like it wasn't that uninteresting, but actually, anyone observing it, I think you just sat there and thought, well, yeah, everyone knows they're just going to win the rest of the matches and win the title. So there's kind of a perceived level of competition which was lower than, what there was if you just crunch the actual numbers. I don't know if that makes any sense.
Yeah.
I mean, I was kind of thinking about it because, Daniel was saying a team might win all its games 1-0.
Yeah.
That's more suspenseful than winning all their matches 6-0.
That's true. Yeah, that is true. Yeah. Yeah, I mean, there's lots of things to explore. So I'm very, very thankful for your suggestions. But I mean, yeah, because there's so much to explore. So we right now we need to kind of focus on the main message that we want to convey with this paper, right? But I agree. There's lots of stuff we can add on, right?
Well, before passing on to Alex, I'll give you one more thought, which is you haven't yet. I mean, you went down to season by season, but obviously you can look match by match for a team. And we're thinking about this from the perspective of fans, but I imagine being involved in a really suspenseful match must have some kind of mental effect. Must also be exhausting physically as well, because you're going right to the end and it's very tight. And so I wondered if you might be able to observe the effects the next match. Suspenseful match 1 week, and then what's the effect the next week? Do they lose a game because they're more tired or something like that?
So like spillover effects from one match to the other. Yeah. We thought about that, but yeah, so far we didn't implement
so far, finite time.
Yeah, but yeah, I totally agree. It would be very interesting. Yeah.
Alex has got a question.
So just looking at this table, I'm wondering what's the standard deviation of both Lance Suspense, Lance Surprise, average player rating? Because if I understand correctly, a change in 1 unit in average player rating increases attendance by 400%. Do you understand correctly?
Yeah, but the average player rating is like a really, really small. So a 1 unit change would be. So
that's why I asked what is the standard deviation?
I don't know, but it is a really small number. Okay. So a 1 unit change would be increasingly huge increase. Yeah. But I would have to look it up. I don't know by heart. Yeah.
And Lance Suspense and Surprise, what are the standard deviations?
I don't know, but here you can interpret it. Here it's basically a 1% increase in suspense is 0.4% increase in audience. So it's not like a tremendous, but in absolute numbers, it's still something, right? I don't know it by heart, the standard deviation.
Thank you.
Thanks.
Thanks, Alex. Danielle, is your hand still up on purpose?
No, sorry, I can't lower it.
Okay, I think I can lower it, so I'll lower it for you.
Thank you.
There we go. Any more questions and comments for Raphael? Okay, well, thank you very much, Raphael. Thanks to your co-authors as well, Tim and Travis, for a really interesting paper. Wish you all the best as you take that forward and develop your work. So thank you very much for that. Thanks everyone for your contributions.
Thank you very much.
Just as we wrap up, obviously there's lots more people here than there were when we started. There are deadlines for conferences on Monday. Raphael's conference in Zurich, second workshop on economics and natural experiments. And then there's also that's deadline on Monday, stuff in the chat, stuff in the email reminder. And the 11th Football and Finance Conference in Duisburg, deadline is also on Monday. And then the Kion Sports Economics Conference deadline is on Tuesday. The only other thing to say is that at the moment we don't have a talk scheduled for next week. So if you would like to present, there is a free spot if you would like to. Let me know if you want to. And if we get a volunteer between now and next Friday, we will have a talk and I will let you know. Otherwise, our next scheduled talk, if I can get back to next scheduled talk, will be on the 25th of April. So after Easter, when we'll have Georgi Shukhailo from the University of Michigan on stubborn scorecards, analysing, I can't even see it because we're analysing belief, perseverance and group dynamics in mixed martial arts judging. So we'll expand the number of sports that have been covered in the Roses series after Easter. But hope to see you before Easter and wish you all a very good weekend. Thanks very much, everyone.
Thanks.
Thanks, Raphael.
Thank you, Raphael.
Thanks, James.